Hello everyone, I am Anikate Koul and today we'll be discussing the 11th problem from the CP-31 sheet by TLE Eliminators under the 1200 problems. So I'll be moving to the CP-31 sheet and we can see that the 1200 parameter has been marked, and I'll scroll down to find my 11th problem removing smallest multiples. Let's begin. Now the problem statement is as follows. You are given a set S which contains the first n positive integers from 1 to n. You can perform the following operations on S any number of times, possibly 0. You can choose a positive integer k where k lies between 1 and n such that there exists a multiple of k in S. Now delete the smallest multiple of k from S. This operation requires a cost of k. You are given a set T which is a subset of S. Find the minimum possible total cost of operations such that S would be transformed into T. We can show that such a transformation is always possible. Now coming to the constraints and the input format, the first line of the test file would contain a single digit T denoting the number of test cases which can go to n power 4. Then the first line of each test case would contain a single integer n denoting the size of our array, and that can go up to n power 6. Then the second line of each test case would contain a binary string of length n describing the set T. The ith character of the string is 1 if and only if I is an element of T and 0 otherwise. It is also guaranteed that the sum of n overall test cases does not exceed 10 power 6. Now you have to output for every test case one non-negative integer denoting the minimum number or minimum possible total cost of operations such that S would be transformed into T. Now as we have read the problem statement, we can try to understand it a bit better, right? So what we have been given in our problem statement is two things, n and s. N is an integer, right? And s is a binary string. It is a binary string. Now n denotes the size of our set. So as we have already a string s, can I choose a different name? What's the name given here? Okay, they didn't give any name because set s is also there, so I won't be using the variable name s. Let's say I use the variable name a. So let's say a is a set and this set initially contains all numbers from 1 to n, right? Now we have to transform this set A into our set B, which is definitely a subset of A, right? But what are the elements of B? Let's see that. Now the elements of B are described by the string S. So if S of I is equals to 1, that means I is present in B. And if S of I is equals to 0, then I is not present in B. And that is how you find out what all elements are present in B. Now, what the problem states is that you can perform a single type of operation. In this operation, you can choose some value k, right, where k follows this inequality that k is greater than equal to 1 and less than equal to n. Also, k should have at least one multiple inside the array or the set A, right, at that point of time. Remember that because the set A is constantly changing. So at that point of time, k must have some multiple inside the given array. Now a multiple means that k is a multiple of itself, right? So k, 2 into k, 3 into k, so on. Remember that k is a multiple of itself. Now once you select this number k, what you can do is delete the smallest multiple. So delete the smallest multiple of k, and this will cost you k units, right? You can say units or anything, right? So the cost of this operation is k, deleting the smallest multiple of k present in A at that point of time. Now keep repeating this process until your set A is converted to set B. Now what you are asked is to print the total minimum cost. So for one operation, let's say the cost was k. After all those operations, let's say total cost came out to be some value c. So this c has to be minimized, right? While converting your set A into set B. This is our problem statement. Now let's see a sample case to really understand what is happening. So this one is quite trivial. So I think we can use the second one. Let's copy this test case and let's paste it here. Also, I will try to move a little extra and also increase the font size. Great. So in this test case, 7 is our n and this is our string s. Right. Now it means that initially our set A would be equal to 1, 2, 3, 4, 5, 6, 7. Right. And our set B would contain the elements 1, 2, 4 and 7. And why is that? Because if I use the indexes, so it is 1, 2, 3, 4, 5, 6, 7. All the indices which have the value equal to 1 are present. So 1, 2, 4 and 7. So that forms our B. Now I have to transform A into B using minimum cost. Right. So what can I do? So for the first part, I can choose k equals to 3, right? And the smallest multiple of 3 in my array or set A is 3 itself. So I'll remove 3 and my cost is increased by 3, right? So the cost is equal to 3 now. And my set A would be transformed to 1, 2, 4, 5, 6, 7, right? And then what I can do is actually again take k equals to 3 because there is still a multiple of 3, right? 6 is a multiple of 3 and it is currently also the smallest multiple of 3 present in my set A. So I'll remove this as well, right? So I remove 6 and again I incur a cost of 3 because my k was equals to 3. Now the cost became 6, right? And my set A changed to 1, 2, 4, 5 and 7. Lastly, I would also have to remove 5 and that is by choosing k equals to 5. So again a cost of 5 and that changes our total cost to 11. And my set A becomes 1, 2, 4, 7 which is also equal to set B and this took a cost of 11. And we can prove that no matter what operations you do, you cannot go below 11. And if we verify it with our output cases, yes, it is 11. So we are good to go. Now, once you have discussed the sample cases, let's move on to discuss the equity and complexity. Now, if we go back to our problem statement, we can see that it is given that sum of n overall test cases has a bound of 10 power 6. Now, keeping that into mind, we can say that instead of writing a total time complexity as O of t into some function of n, I could write it simply as O of some function of n because n in itself has a bound overall test cases. Sum of n overall test cases should be less than equal to 10 power 6. But also keeping another thing in mind is that in 1 second on Codeforces, we can run about 10 power 8 elementary operations. So if our time complexity comes out to be O of n, then that takes around 10 power 6 elementary operations and that is well below our limit of 10 power 8. Even a time complexity of n log n would consider to be 10 power 6 into 20 because log base 2 of 10 power 6 is approximately 20 and that is around 2 into 10 power 7 and that also fits our criteria of 10 power 8 pretty easily. But if we move on a step further and try to have a time complexity of n square, then that comes out to be 10 power 12 operations, which is much higher than our desired limit of 10 power 8. That's why we can say that our expected time complexity has to be in the vicinity of O of n or O of n log n. Now, once we have discussed the expected time complexity as well, we can start to discuss the solution. Now, one important observation to note is that we can delete elements in any order, right? It is not mentioned in the problem that the elements have to be deleted in increasing order or decreasing order, right? So it is completely up to us. So what would be the most optimal way of deleting an element, right? So if we take a value like 12, right? I can, in some case, I'm not saying in every case, but in some case, I can choose my k equals to 1 and delete 12, right? If there are no elements between 1 and 12. So if I have some array which is currently 1 and then next element is 12, so I can choose k equal to 1. Okay. No, right? K equal to 1 is not possible, sorry, because then you would have to delete 1 first. But let's say if k was equals to 2. So I have 1, 2 and no elements in between and straight to 12. So I can uh, choose k equals to 2 and delete 12, and that will take a cost of 2. But if I choose a k equals to 3, let's say in some case I have 2, 3, 10, 12, right? And I can delete 2 first, like I would do here. I would delete 2 first and then delete 12. Here also I would delete 3 first and then delete 12. Even if I choose k equals to 3, even then I can delete 12, right? So that would take a cost of 3. Similarly, I could choose in some case k equals to 4 and in some case k equals to 6 or even k equals to 12, and using all these k's, in some case or the other, I would be able to delete the value 12. But as we are trying to minimize our total cost, obviously I'll try to prefer k equals to 2 first, right? I would always prefer to delete 12 using my k equals to 2. If that is not possible, then I would move on to k equals to 3. And if that was also not possible, then I would move to k equals to 4, then k equals to 6. And at last, if nothing is possible, then I would have to choose k equals to the value itself, that is equals to 12. So this is a very important observation to note, that when we are trying to delete an element, we'll try to choose the smallest k possible through which we can delete the element, right? So keeping this important observation in mind, let's try to formulate some logic, right? Let's say I choose k equals to 2, right? So obviously first I'll have to check if 2 is present in my array A or not, right? Or the set A or not. So if 2 is present in my set A, then obviously I'll have to delete it first. And I can delete it only if it is not present in B. So I can delete 2 only if 2 does not belong to the set B, right? If it belongs, then I cannot delete 2. And if I cannot delete 2, for any number, I cannot choose k equals to 2, right? Because 2 is the smallest multiple of 2, and if 2 is not deleted, then I cannot delete any further elements, right? Similarly, for any number, let's say if I choose k equals to 5, I'll have to ensure that 5 is deleted first. And if 5 is deleted, then I have to check if 10 is deleted or not. So if I have some value 20 and 10 is still present in my set A, I cannot delete 20 until I delete 10 and I delete 15, right? So keep these things in mind. Now this was our second most important observation, and now clubbing these two observations together, we can do something of this sort. So I will choose some value. I start from 1, right? I'll choose k equals to 1, and then I'll keep checking for all the multiples of 1. So 1, 2, 3, 4, so on till n. So let's say 1 was deleted already, or we have to delete, right? So if 1 is not present in B, I will simply delete 1, right? Using k equals to 1. And let's say if 2 was also not a part of B, 2 was also not a part of B, so I'll delete 2 as well with a cost of 1, right? But let's say 3 was a part of B, right? 3 belongs to B, so that means I cannot delete 3 from A, right? So that means using k equals to 1, I cannot delete any elements from 3 till n, right? Because I cannot delete 3, so I cannot delete any elements after 3 as well. Now, once I've exhausted all the possible options for k equals to 1, I move on to k equals to 2, right? Let's move on to k equals to 2 and let's see what happens. Again, I'll check if 2 is deleted or not, or can I delete 2 or not. If 2 does not belong to B, then I'll delete it. But just keep a small thing in mind. Keep checking if 2 was already deleted or not, because it can happen. Like in this case, that I used k equals to 1 and deleted 2. So you don't want to delete 2 again, right? You don't want to overcount. So let's say 2 was deleted. Then I'll check 4, right? Is 4 deleted or can I delete 4? Let's say I can delete 4, so I will delete it, right? And then I'll check 6. Let's say now 6 is a part of B, right? So I cannot delete 6, right? So I can say that I cannot delete any elements from 6 till n, which are a multiple of 2. Similarly, I keep doing this for every value k equals to 3, so on till k equals to n. I exhaust all these values, and this will ensure that for any value or any element I delete this element I using the smallest k possible, right? Because I'm iterating from 1 till n with this k. That means I can ensure that for any element I, if I have to delete this, then I will be choosing the smallest k possible to delete this element, right? Now, the logic must be clear, but the only doubt that few people might have is what is the time complexity of this approach, right? Because it seems that for every element, I am running a brute force, right? I'm checking all the multiples of every element. So, will it go till n square? Let's see. 1 has n multiples, right? Which are less than equal to n. So, if I'm trying to count the number of multiples of 1, which are less than equal to n, there are n multiples. For 2, there are n by 2 multiples. For 3, there are n by 3 multiples. For 4, there are n by 4 multiples, and so on. And n has only one multiple, which is less than equal to. So, these are the number of iterations as well, which I would have to perform. So, if I add all these values, that would be the total number of iterations that I have to perform, right? So n plus n by 2 plus n by 3 plus n by 4, so on till n by n, which is equal to 1. Now, if I try to calculate what sum does it represent, let's see. Let us take n outside and let's take it common, and then it is 1 plus 1 by 2 plus 1 by 3, so on till 1 by n, right? Doesn't this represent log n? So it is not log base 2 of n. I think, if I'm not wrong, it is natural log of n, which is also known as ln of n. So, but ln of n and log base 2 of n only differ by a constant, right? So if you multiply some c into log base 2 of n, you can convert it into log base e, the natural number of n. So it does not make a lot of difference, because whenever you're calculating a time complexity, we often ignore the constants, right? Because we are trying to find the asymptotic time complexity. So that means I can say the overall time complexity would be around n log base 2 of n, right? Because as I said, we can approximate log base e to log base 2. So my overall time complexity would be in the vicinity of n log base 2 of n, which is in fact, as I discussed, around 2 into 10 power 7, which is much lower than 10 power 8. So we are good to go with this approach. Now, as we have discussed the approach, I think we can move on to discuss the implementation part as well. So let's see the implementation. Now, for I'm taking input for the number of test cases, and then for each test case, I'm taking the input for the size of our initial set A and the string S, right? Now I maintain a variable answer, which is going to store my final answer, or the minimum number of minimum cost that I have to bare to convert my set A into set B. Now this vector is a vector of booleans is saying is removed. So this vector will store whether an element is removed or not. So it stores whether an element is removed or not. Right. Now I simply run a loop from 1 to n, and then for every value what I do is I run a loop over its multiples. Right. Quite simple. Now what I do is I check. Right. So as I said, let's say I'm at 2. So I check if 2 can be deleted or not, and then 4 can be deleted or not, or 6 can be deleted or not. So if s of I or s of j minus 1, so I'm using minus 1 because the string s is in zero base indexing. So I have to use a minus 1. So if some multiple of I cannot be deleted, because if the value is 1, that means it cannot be deleted. So if that multiple cannot be deleted, so the multiples after it also cannot be deleted, right? So let's say if k was equals to 2 and I am currently at 6. So if s of 6 minus 1, that is equals to 5. So if I write s of 5 is 1. So if s of 5 is 1, that means I cannot delete 6, and that means I cannot delete all multiples of 2 after 6, right? So cannot delete multiples of 2 after 6. Great. So whenever I see the first element which I cannot delete, which is a multiple of our I, then I simply break because I cannot delete the further multiples as well. So there is no use of checking. Now this is very important part. As I said, we have to check if that element was removed or not. Right. So if that element was already removed by some previous k, then I don't want to remove it again. Right. I don't want to overcount as I said. So if it was already removed, again, I just continue. But if it was not removed, I remove this by writing is removed of j equals to true. And then I also add the cost to remove it, which is equals to I. Right. And doing this for all elements from 1 to n, the cost is O of n log n as we discussed, and I simply print the answer, right? So now the total time complexity would come out to be O of n log n, and the total space complexity would come out to be O of n, right? These are our metrics. Now, as a final remark, I would like to say that this problem was quite interesting because the first fact that it had a really good time complexity analysis, because a lot of people might think of this approach and then may not be able to judge properly what is the time complexity. They might think that it is O of n square or somewhere near that, and they would reject it. So it is very important in this question to actually calculate what would be the approximate time complexity so that you can accept this approach. Even after that, this logic is quite fascinating, that you can brute force almost over all elements from 1 to n and still fall within the time limit for this problem, right? So I hope you like the solution, and see you next time.